Okay, I would have started this talk with a small joke, but seeing the condition of stand up comedians, I'd rather start with my topic. So, that is adding attention to the domains. So, starting from my topic only, uh, what do you think about AI? What actually is AI? If you would have asked me 3 or 4 years back, what actually is AI? I would have a very narrow scope of answering that. That is from the machine learning and the deep learning perspective, right? We have a lot of data. We have tabular data. We have unstructured data, and then we are planning it in a way to feed it into our system so that it can answers the question on the basis of that. There was no concept of LLMs. There was no concept of generative AI as such, right? Then comes the part of 2021, where there comes the LLM, where there comes the open AI, right? Then we were introduced to generative AI. Then we were introduced to answering the questions those you were asking to that, right? So that was only possible because of the data that we were producing, and we were feeding that to the system so that it can answers our question. Perfect. So there was certain uh, uh, okay, so in this talk what we are going to include, first one is the agents. What is agent? Then after that we have LLM, then we have the vector databases. All right. So I think the vector database right now is a very big thing because generative AI or LLM, you can say, are only trained on the 5% of the total available data, right? That means it is only trained on the 5% of the publicly available data, right? If you have your own data, you have your own spreadsheet, if you have unstructured data, how are you supposed to get the answers from the LLM on that data, right? That is one thing where the vector database come into the picture, and the LLMs for short. Yeah. This will be the flow of the presentation. This will be the flow of the entire talk. First, we'll have a look about the case studies. What is actually being done? What is like the good practice of doing things, right? Then we have the idea visualization. The majority of things from the LLMs, the majority of things from the AI that has been already covered by the three talks that we have seen earlier. So I try to mold it in a way that it is more of a idea visualization kind of presentation, so that in the end you can create some your own ideas. You can brainstorm on those ideas so that you can create some good and viable product from that. Then after that, we have the impact on the different domains. We have multiple domains to work on in the AI as well. So third step will be that, and the fourth step will be explainability. So I think in every talk, everybody have mentioned it. You need to be accountable for the system that you are building, right? It should be explainable in a term that, okay, so if it is giving you some sort of suggestion on the basis of the previous data, it should actually tell you what were the parameters those were considered earlier as well, so that this was the entire output from that model. Perfect. All right. So we'll start from the healthcare. We'll start from a story. Okay. So you are living in a neighborhood, and in the morning, you take your dog for a walk, right? And your neighbor is there, and her daughter is having some sort of issues in her back, right? They have been to multiple hospitals. They have like had a conversation with a lot of doctors, and no one was able to actually find what actually the issue is, right? So this is a case, and you are a software developer or you are a tech guy, and the open AI and the LLMs are just came into the picture, right? Then you give her a suggestion. Why don't you try using LLM? Why don't you feed the entire reports of your previous visit? Why don't you like feed everything that you have for that particular patient, right? Then what the lady did is she took all the reports, she took all the feedbacks, and pasted that as it is in the LLM, right? What happened next? It gave the results those were not given by the 17 doctors combined, right? So it was able to predict, okay, so this is the problem. This is the problem the daughter of you is facing, right? So this is the first case study. Then second case study is, okay, so this scenario is done. Okay, then after that COVID comes, right? And you can't go outside. Of course, you have faced it. you can't go outside, and there are a lot of things. And one of the patient, there is somebody who got infected from the COVID-19, and there is no cure for that at particular time. There was no vaccine available for that at that particular moment. Then what you did was, you took all the reports of that patient, and also the kind of okay, so you have added a lot of context from the basis of the books as well, right? Those are available to you. Then after that, AI was able to predict a medicine that was related to arthritis. It was somewhat related to like, okay, so these are the kind of things that I've been like facing. You should take this medicine, or you should do something with this medicine. So what you did was, you sent an email to FDI, right? And FDI tested it, and it sorry FDA, and it approved it. Reason, because it was so much close to uh, predicting a drug, so that it can easily vanish away that particular problem, right? It wasn't of course that 100% sure, but still it was somewhat similar. So on the basis of that particular DNA, on the basis of that particular drug, you were somehow able to make a medicine from that, that could able to cure COVID-19, right? So these were two case studies or scenarios, I would say. Only thing that is fiction about is you weren't there, right? It has happened. So this is how the healthcare is being shifted towards the AI, because there is a limit to retain the memory in the human mind. But if you talk about the LLMs, yeah, sure, it does hallucinate. It will give you the results. Those are not good, but still, it has a very long context window, right? So you are getting a lot of answers. You are getting a lot of context from it, and you are putting your questions. It will give you results on the basis of that. And adding the vector database to it, it will like act like a superhuman, right? Okay. So, from these two case studies, what are the possible ideas to work on? First one is, let's consider healthcare in two segments. First one is the mental health, and second one is the physical health, right? In the mental health, what happens? Uh, Actually, I have talked to a lot of mental health professionals. Uh, if you have a good vocabulary, if you are able to tell, okay, so this is something that I am feeling, that one word that you can catch, you will be like cured in 6 months maximum, right? So the major thing is, in the healthcare of the, like in the mental health care, the right word is very difficult to find, right? So first thing is that you can use something in the healthcare. Then after that, we have the physical health. In the physical health, if you are visiting a doctor, all right, and he is using a system where everything is being transcribed on the real time. Let's suppose you are saying something, and it is being transcribed on the way, and the doctor is saying something, it is also being transcribed on the way, and you have a fine tuned model, or let's say a general prospective model, that is there to answer the questions on the basis of that particular transcript of yours, right? You are involving the human in the loop. You are also involving the AI in the loop as well, right? So that is something, a product that you can make from it, right? Then after that, we have the machineries, of course. uh, okay, so AI system matched or outperformed the doctors in the task, like skin cancer detection and the radiology scans, including humans in the loop. Of course, you need the human. There is one slide I have added in the last as well. So that is already that is responsible for the kind of predictions that you are getting. Let's suppose there is a guy in your neighborhood, and he visited to a vet. He visited to somebody, right? And uh, the doctor told him he is having cancer, right? So what is going to be the first question the neighbor is going to ask? Why me? And second question will be, how it is happening, right? So these are the two things you will not only ask to the human, you will also ask to the your AI system as well, right? You can't just say, okay, so this is trained on this sort of data, and it is getting the prediction on the basis of that. You should be liable for that. there are two things. First one is the explainability, and second one is like uh, you are able to explain the model, right? So these are two different things. We'll cover that in the later part. We'll move next to the education part. And in the education, I won't necessarily include the traditional education, not only from the second grade to the high school, elementary and high school education. I will include every sector into it, from the financial sector to the legal section to the development section, and everything, right? Everything is there. So in the development sector, I guess majority of you guys from the development background, right? How many of you are from the engineering background? Can you please raise the hand? Perfect. So, in the development, you have already seen the progress. You have already seen the transition, right? Earlier, what used to wait a second. I have this. Yeah, this is a number. 3 million repos were created till 2013 and 5 million till 2015. 2 years, 2 million gap. I need you to answer me. What do you think? How many repositories do we have right now in 2023? We have around 300 million repositories. And this is the data till 2023. And now the AI have come into the picture in the developmental stage. We have cursor, we have a lot of tools. Those are deploying it for you. You don't have to do anything. You just have to okay, git push this, and that's it, right? So this is how the AI is actually impacting the developmental stage. Then we have one more thing that is being transitionized, the hierarchy, that is the way the companies are operating, right? So what happens is, first, if you are let's suppose you have a idea, right? You are in an ideation stage and you want to build a product out of a company, and you visited some company and okay, so I want this product, right? And these are my requirements and I am willing to spend this much of the amount. Perfect. So what you will do is you will first visit the sales department or the business analyst, right? He will okay, so he will understand all your requirements, and after that he will pass those requirements for the CEO or the CTO to approve, right? Then after those requirements are approved, they will start working on that. They will get back to you on the costing and everything like that, right? So in this research paper, this was published in 2024. What they did was they created the entire hierarchy of the uh, organization, right? And in that organization, you are a client and you are just writing the prompt that is the entire requirements list of yours, right? Then after that, it is automatically going to the business analyst. The guy over here in the chat dev is the business analyst. He will reach out to each and every agent. All right, let me give you a fair context of what agent is. Agent is an LLM on which you have defined certain role. All right, so you will act as a business analyst and you will act as an engineer, giving some sort of context and attaching some sort of RAG pipeline to it, right? It will go to that. It will give you the results. It will okay tell you all about the costings. Okay, so these are the costing. This is the estimation that we require to build a product. Then after that, after that, the estimation is being done. That will be passed on to the developer, right? And one more thing, you think agent work in a flow? Okay, so this is an agent that is creating something, and someone else is testing for that. That's not at all the case in like if you are talking about the good agents. You can define the agents in a way that it is in a hierarchy and it is also solo, right? What do I mean by that? First one, let's suppose there is a entire team of the AI engineers. Those are solely the uh, front end engineers, right? There is a hierarchy for that. Then there is the back end engineer, then there is an AI engineer, and everything that you need for that particular project. There are tools, of course. Let's suppose you have to integrate calendar to it, so there's a tool that can integrate that calendar to your organization. Perfect. So first the backend will be handled, let's suppose. All right, then after that, that backend will be sent to the testing agents, right? And what about the testing agents? Let's suppose if you are using a normal LLM, and if you type okay, so I need a code for writing a Fibonacci series, it will give you the code. Then you have to run it on your system. That means you have to use your own CLI. That means you have to use your own memory. Perfect. But in this case, there is one agent that is the CLI, of course, that is the entire execution agent. You have built a backend that will be transferred to that particular AI agent. Then it will execute that, and it will give you the errors. First one in the let's suppose in the first iteration, there is one library missing, that is NumPy, right? So there will be a error in the CLI that okay, so this library is missing. Then that feedback will be backly transferred to that particular backend agent. All right, so I want to write you the code in the basic on like in a way. I want you to do the changes in a way that it should run, and this was the error in that. This library was missing. So you add that library and you go back to that particular agent, and everything is running smoothly. Then everything is done on the front end, on the back end, and the AI. Then after that, that will be passed to the testing agent. Everything will be tested, right? There will be a lot of test cases on the basis of the code that you have written, and those test cases will be run on your system, and the reports will be generated through it. How much memory was taken, how much time was taken, and like did the test case even pass or fail, right? So these are the kind of things on a whole that will happen inside the engineering team, right? When the entire product is built, it will be handed over to you. So that was the entire hierarchy of the paper. And this wasn't only a theoretical concept. Uh, they actually build a game. I don't know exactly the name of the game, but they build a game entirely in 8 minutes, and you were able to see the agents interacting with each other, right? So there was an agent that is telling, okay, so the code wasn't good, so they texted back, okay, so do some changes, and all right. So these are the kind of things in the developmental stage, I think, is impacting the development, right? Then after that, we have this, of course, we have reviewed it. Then after that, let's go to the third case study, that is the Mastercard. All right. So back in the days, first thing, frauds are inevitable in banking. That's a statement, right? Period. And after that, like you can minimize them. You can only minimize them. So earlier, what used to happen was there was data, and people were monitoring it and getting the results. Okay, so this is fraud. This is something. This is something. This is approved. So there were a lot of false positives, and the time taken was very huge, right? Then they used the machine learning approach. What they did was they did clustering of each and everything. They found out the outliers. Okay, so that was also a time consuming process, as your data is changing day by day, right? So you were able to do that, but after a certain time, when the agentic AIs and everything came into the picture, they used the AI to do that, right? So there is one thing about the traditional AI, the generative AI can do that, right? If you are prompting, I want this is my data, and this is the entire information about the data, the number of rows, how many standard deviations, whatever it is, right? Then after that, it is passed as a pipeline to the model that the generative AI already have built itself, right? It was working on that. Then after that, what was the result? 200% less false positives, first things. And they were able to save actually a lot of time, right? So this was a case study by the Mastercard. Then after that, we have the JP Morgan. They have built an AI system called the Coin to handle the tedious task of reviewing the legal contracts. How many times have you made a product and thought, okay, so this will be not legally fit? Or let's suppose if you are shifting your home, there'll be a lot of legal paperwork. Or let's suppose if you are taking a car, if you are taking a loan, there are a lot of scenarios where the legal work is involved, right? You aren't able to like read it all. You are not able to understand what is clause 30, what is clause 50, what is article, and all these kind of things. But if you are passing that entire legal document to an LLM or an agent that is built for that, it will give you the insights. It will tell you on what cases your insurance is valid, on what scenarios your like you have to empty your home, and all of the things like that, right? So you can use the AI agents in a way that it can answer the legal aspect as well, right? Then after that, we have the ethical concern. uh, that is the main thing, right? Okay, so there will be a lot of false predictions, there will be a lot of errors, there will be a lot of false outputs, right? So there are two ways to deal with it. First one, uh, take a human in loop. Let's suppose, y- okay, so there is a self-driving car in India, and some policeman stops it. Who is able to answer the question? Who is liable for that? Yeah, of course. No one is there. No one is sitting here. You are sitting on the back seat. Who is able to answer that? Nobody, right? So that is one thing. You have to have a human in loop. Second thing, it should give you the features on the basis of what it predicted. Let's suppose, let's take the example of healthcare once again. Someone told you you are having a cancer, right? And it was fed a lot of your past history, lot of your data, according to you, okay, your age, your gender, everything like that, right? And uh, after that, it is giving you a prediction, okay, so you are positive for the cancer. How is it supposed to tell you it gave you the results on the basis of these particular features? What was the reason? Why did the model performed the way it is performing? So there is a field of study, entire field of study called XAI, not of the Elon Musk, of course. That's the explainable AI. What it does is it will break down your entire model into sub models, right? That will be computationally very inexpensive. First of all, it will break down the model. Then after that, it will give the input that, let's suppose your data was an input, and the output was, okay, so age was the major factor because of which you are having a problem. I am taking example of age. There might be some other reasons as well. Let's suppose you had some sort of disease in your past days. That is the main reason for giving you this kind of output, giving you these kind of predictions, right? So this is the point where the explainable AI comes to the picture. And if you are seeing this feature, this is the feature which is solely responsible for giving you the predictions that, okay, so you are having some sort of disease. So that is not only applicable for the healthcare domain, that is applicable for each and every domain, right? These are the ethical concerns that, and yeah, one more thing. There is one more field of study that I think is emerging right now if you want to work on that. Ethical AI is valid for the traditional algorithms. Ethical AI is valid for the deep learning, machine learning, and all these kind of things. It's not applicable for the generative AI because generative AI is based on the transformer architecture, and yeah, perfect. So it is based on the transformer architecture, and you aren't able to predict, okay, so what will be the next word that will be coming, right? So ethical AI won't fit into the picture. But let's suppose if you are creating an agent and there is no human in the loop, how are you supposed to evaluate it? Let's suppose there's a QA task and you are getting a test case out of it, right? And the test case is not running because the test case is not according to that particular code. How are you supposed to find a matrix? Okay, so this is the false positive, like this is the false positive, this is the false negative, and is it right or not, right? So this is a major field of study where the explainable AI have come into the picture for the agentic AI, right? So that is something you can work on, of course. All right, so this was my entire talk. Thank you.